Alright guys, we're going to integrate this using u substitution. What you first got to do is find the inner piece. The inner piece is what we call it. We call it u. And what happens is you find something, an inner piece, that when you derive it, you get another piece there. And so what you look for, you go look at this and go, oh, if I derive that, I get this. Alright, so I'm going to call that inner piece u. Okay. Now, next, I'm going to derive u. When I derive u, don't you have du dx equals 2x? Okay. Then you make it into a differential. Do you guys remember? To make this into a differential, don't you just multiply both sides by dx? And you end up with du equals 2x times dx. You guys just remember both sides by dx? We now have our differential. Can I make this replace that? Is that the same thing? Can I have this? Oh, sorry. Could I have this replace this? Can that u replace that? Can I now have u to the third du? See right here? Doesn't du equal this? So I can replace du with this. And here, doesn't x squared minus 9 equal u? So can I replace it with u? So I have u to the third du. Can I integrate that now? It's really trippy and weird. It works. If it's one that works. Now, just integrate this. Okay. The answer is simply going to be u to the fourth over 4 plus c. What do you think the next step's going to be? Put u back in. And u was x squared minus 9, so my answer is x squared minus 9 to the fourth over 4 plus c. That's all she wrote. It takes some practice.
That's it?
Yeah. All right, let's do it again. Which one do you think is the inner piece? Which one, when you derive it, will you get the other piece? Usually it's something inside of something. See right here, it's inside of a square root. Usually it's a giveaway. And when you derive this, will you get something like that? So if I make u 1 plus x to the fourth, when I derive that, what do you get? Well, you get du. I'm going to make it a differential right off the bat. Won't it be 4x to the third? Now, does this match that x to the third? That's 4x to the third dx. I want x to the third dx, right? But could I just move that 4 over here with the du? Watch this. By the way, this is a differential. I derived it and moved the dx all over in one step. If I divide the 4 over, I now have du over 4 equals x to the third dx. Does this match that? So can I replace that circle with du over 4, or 1/4 du? Could I also take this and replace that with u? So what I now have is I now have, for the top piece, it's du over 4. And for the bottom piece, I now have the square root of u. The top piece becomes du over 4, and that's still the square root of u. Now, can I rewrite this? Can I take the 1/4 and just take it out front? And then wouldn't this be 1 over the square root of u du? Because won't this square root u jump in there with the 4? And then can I pull the 1/4 out? Is this integratable? Integrable? Yeah, watch this. That's 1/4. Isn't this u to the negative 1/2? Doesn't that give us, we add 1, isn't that going to be u, 1/4 out front, times u to the 1/2 over 1/2? Which this 1/2 flips, and you end up with, for some of you this might be kind of tough, but u to the 1/2 over 2 plus c. And can I go back and find u and plug it back in? So it's going to be the square root of 1 plus x to the 4th over 2 plus c. There's your answer.